Here we go, day one notes. We're going to get this right this time. So, this is the deal. We're going to talk about arithmetic and geometric sequences today. I'm going to give you 3 different videos to watch. I'm trying to make them small and short. First one we're talking about is arithmetic sequences. You'll remember back from your secondary 1 days, you learned about sequences. That's just a pattern of numbers. When there's a specific way that they increase or decrease, they can be considered arithmetic or geometric, and today we're going to talk about both of those. So when a pattern either increases or decreases at a constant rate, meaning you either add or subtract the same number every time to get the next term, that is called arithmetic. Notice here, to get from 3 to 5, you added 2. From 5 to 7, added 2. 7 to 9, added 2. So you're adding 2 every time. That's called an arithmetic sequence. There's 2 different types of equations we're going to look at, a recursive and explicit. So the recursive equation deals with knowing the previous term. Okay, so you always have to state where you begin. And you can either do it in what's called function notation or subscript notation. Okay, either one's totally fine. Function notation, that's this one, f of 1 equals 3. That means the first term is 3. You'll notice that's our first term, 3. Then to find the recursive equation, you say f of n equals the previous term, f of n minus 1. That's what n minus 1 means, the previous term, and then plus 2. If you do a subscript, you'd write a sub 1 equals 3. Again, that's the first term equals 3, and then a sub n equals a sub n minus 1, the previous term, plus 2. Now, that works great if you're doing maybe like, I don't know, up through the first 10 terms. But what if you want like term 100? Well, you don't want to have to find 99 terms to figure out what the 100th term is, because a recursive equation would basically tell you that. You'd have to know the 99th term to figure out the 100th term, because then you would add 2 in this case, or whatever you're doing. So there's another way we can do it, which is called an explicit equation, which means you can just plug in what term you want, and it will produce what that number is. So here's one way to do it with function notation. You start out with your first or initial number, 3, so the first term, 3. Then you have your common difference, we added 2 every time, times n minus 1. In subscript notation, it looks just the same. Again, we have the first term, and we have our common difference of 2 times n minus 1. We could, in general, write it kind of like this. F of n equals f of 1, which is our first term, plus the common difference times n minus 1. It's just kind of a general equation. So let's look at this on number 1. Write a recursive equation, so we want the recursive one. So that means we have to first state where we began. F of 1 started, the first term was 6. Then we would say f of n equals the previous term, f of n minus 1. What's it doing every time to get to the next number? So from 6 to 4, subtract 2. 4 to 2, subtract 2. 2 to 0, subtract 2. 0 minus 2, subtract 2. So we just take the previous term, minus 2, recursive equation, done. If you want to write it in subscript notation, you'd say a sub 1 equals 6. So again, stating where it began. Then you'd say a sub n equals a sub n minus 1 minus 2. Done. Let's take a look at number 2. It says write an explicit equation for this sequence. So negative 5, negative 10, negative 15, negative 20. So explicit equation would say, okay, I'm going to start with my first term, negative 5. Then I'm going to add, what is the common difference? How do I get from negative 5 to negative 10? Well, I multiply by negative 5. I subtract 5. From negative 10 to negative 15, subtract 5. Negative 15 to negative 20, subtract 5. So that's known as my common difference times n minus 1. And again, plus a negative really would just be minus. So if you wanted to, you could really actually say that it's f of n equals negative 5 minus 5 times n minus 1. With subscript notation, we just say a sub n equals a sub n minus 1. Sorry, not a sub n minus 1. Let's undo that. Remember, we start with what we began with. We started with our first term, negative 5 plus a negative 5 times n minus 1. Okay, that is our explicit equation. Number 3 says find the first 3 terms of the sequence. If I want to find the first 3 terms, that means I want a sub 1, I want a sub 2, and I want a sub 3. Why did I not use f of 1, f of 2, f of 3? I could have, but they were with subscript notation, so I just stuck with it. Okay, 2 ways to do this. You could just take 1 and plug it in for n. 1 minus 1 is 0. 3 times 0 is 0. 7 minus 0 is 7. Or you could have remembered that this was your first term, because this is an explicit equation. How do I know it's explicit and not recursive? Because there's no a sub n minus 1. If it was an a sub n minus 1, I would know it's recursive, because that would mean I would need the previous term. So now, what does this minus 3 mean? That means that that's the repetitive difference, or the common difference, the thing I'm doing every time. So I'm minusing 3. So 7 minus 3 is 4. So if I plug in a 2, I should get 4. 2 minus 1 is 1. 3 times 1 is 3. 7 minus 3 is 4. Okay, if I subtract 3 again, I should get 1. Or if I plug in a 3, I should get 1. 3 minus 1 is 2. 2 times 3 is 6. 7 minus 6 is 1. I get it. All right, find the first 3 terms of the sequence. A sub 1 equals negative 5, so I already know a sub 1. It's negative 5. I'm going to find a sub 2 and a sub 3. What do I do? Well, to get there, I use a sub n minus 1. This is a recursive equation. So I take the previous term, and I add 4. Negative 5 plus 4, negative 1. Negative 1 plus 4 is 3. Okay, you're done. I'm done with the arithmetic, except for the one thing. I want to show you one thing that, one way I like to do the explicit equations, and you don't have to do it this way. I just do it this way because it makes sense to me. I first find the common difference right here, adding 2 every time. Once I find that I add 2, in mathematics, repetitive addition is multiplication. So that gives me 2 times n. I know 3 is my first term. So that means if I plug a 1 right in here for n, that I should get out 3. So 2 times 1 is 2, not 3. How do I get from 2 to 3? I add 1. So there is that's another way to find the explicit equation, 2n plus 1. You might say, is that really true? Well, let's take a look right here at the explicit part, okay? If I look at 3 plus 2 times n minus 1, if I distribute the 2n, that gives me 2n minus 2. And then I have 3 plus that. If I combine like terms, 3 and a minus 2, that's 1. So that would give me that f of n equals 2n plus 1. Same equation that we got up here. Take a look right here on this explicit equation, okay? So again, we said we were subtracting 5 every time. So I get negative 5n. If I plug in a 1, I should get out negative 5. Negative 5 times 1 is negative 5, so I'm good. There's f of n equals negative 5n. You're like, is that really true? Well, distribute the negative 5n. That would give you negative 5n plus 5, and here we began with negative 5. So negative 5 plus 5 is a 0, so you get left with just negative 5n is f of n. All right, that's what we got going on, guys. This is video 1. Watch for the other 2 coming up.